Foreshadowing, next week we're going to talk about conversions and how you would structure how to set up a conversion process. Okay, the question that you're asking about is all about conversions. Okay, so we'll walk through that process on what I would recommend and talk through why this particular conversion process becomes challenging, particularly for students, and ultimately how they fall into the trap of just listening to what a tutor tells them to do with that solve. So let's take a look at this question. Provide the balanced reaction of oxygen gas reacting with hydrogen gas to produce liquid water. Right? At this stage in the game, you should be able to do that. So take a minute, write down that chemical reaction. The nomenclature and a little bit of the reactions within this system. Okay, so where we would start, balanced reaction of oxygen gas. Okay, so if we're going to say oxygen gas, let's go through and start to convert this into a chemical reaction. What's our symbol for oxygen gas? Okay, so O is our symbol for oxygen, so we could drop that in as an O. Okay, I'll get a lot of people going through and saying, well, if it's a gas, we should specify the phase. We can specify that phase with parentheses shortly after it. Right? If we listened real careful to what was shouted out, though, it wasn't just O gas. Right? What was shouted out was O2. Why was O2 shouted out? When we're talking about certain elements, they are defined as diatomic. Meaning when we talk about those elements, we have to see two of them together. Okay? The only time that I will see a single oxygen chilling on its own is when I say an oxygen atom. That's it. If I say oxygen, it's O2. If I say oxygen gas, it's O2. Okay? So you have to know those diatomic elements. Now the question becomes, how do you know what elements are diatomic? You memorize them. There's a variety of ways to go through and do that memorization process. Okay. The one that I believe is in the videos is saying, have no fear of ice cold beer. So it's a mnemonic device to go through and identify the first letter of each of those words, identifying your individual element. Okay. Other approaches. We could start to find them on the periodic table, because when are we going to have a periodic table? Always. So we can look at the periodic table, and if we knew just a few of them, say like nitrogen, oxygen, fluorine, chlorine, bromine, and iodine, we could see that the shape they're starting to make is what? A 7, which would mean how many elements are diatomic? 7, except how many elements made up that shape? 6, which means we missed one.
Hydrogen.
That's the hydrogen. Okay. The other option is you could go through and highlight that shape, okay, as a 7. And if maybe you grew up in the colder areas, you could highlight those 6 elements, and you could highlight this one with a big old circle, and what you've got is a hockey stick and a puck. That also works to identify those 7 elements. Kind of, sort of? Right? So you need to know that. That's part of the language. That's part of the nomenclature for those individual elements. All right, so it says oxygen gas reacting. We've got oxygen gas. Where's the reacting showing up? That's that plus symbol. What is it reacting with? Hydrogen gas. Our symbol for hydrogen would be H. Again, it's a gas. This is the have of our have no fear. It needs to be diatomic. It needs to be H2. Hi. Reaction with hydrogen gas to produce is our reaction arrow. Okay, to produce now liquid water. Water gets a little bit tricky. You could make an argument here that water is not something you're responsible for knowing the formula of, because that's a common name, not a proper name for the individual compound. That said, what's the formula for water? Okay, so since you know it, we kind of just accept that. That is something that you could come back after a test and be like, I don't know the formula for water. You've got an argument. Okay. I don't know where I would fall on that argument, to be honest. I would probably say you should know that. We talked about it a bunch. All right? So am I good now? I need to balance. True. Still not good. I left off the phase. So I got to make sure I include that liquid phase on there as well. Now that I've got everything properly written out with their individual formulas, now I can go through and deal with the balancing process. Everybody does it slightly differently because I wrote everything really big. I don't really have a lot of space underneath. Hydrogen and oxygen. We should start with the hydrogen. Well, actually, in this case, it's ultimately not going to matter. But typically, you would do oxygen last. Why do we do oxygen last? Oxygen is everywhere. It reacts with nearly everything, which means the odds of oxygen showing up in multiple places on each side of the chemical reaction are pretty high. And because of that, it becomes very tricky to balance right out of the gate. So what we hope to do is to balance it last so that I don't have to worry about it and hope that it just balances out on its own without getting to it. So hydrogen on the left, how many do I have? 2. And I'm going to change that statement because I said hydrogen on the left. Could say, well, 1 because there's H2. What we're referring to in this balancing process is the individual atoms. So how many atoms of hydrogen are on the left? There's 2. How many atoms of hydrogen are on the right? 2. So our hydrogen is balanced. We can then move to the oxygen. How many oxygens on the left? 2 on the right? 1, which means the oxygen is not balanced. When we're attempting to balance the equation, the only thing we can change, once we've written out our formulas, is the coefficient in front. Okay? That's the only thing I'm allowed to change. So if my oxygen doesn't balance and I need 2, the only way I can do that is by changing the coefficient in front to a 2. That 2 applies to everything afterwards up to a mathematical operator. So on the right-hand side, I'm going to come back to that in a second. Okay? I've now changed the coefficient. Because I've changed the coefficient, what should I do? I should reset and check all my work. Forget writing over text. How many hydrogens on the left? Hydrogen atoms on the left. 2. Hydrogen atoms on the right. There's now 4. I have the 2 in a water molecule, but I have 2 water molecules. Those are now going to multiply. I get 4 hydrogens on the right. Okay? So now my hydrogens are not balanced. What do I need to do? I put a 2 over here. I don't know if we're going to change that up. Now how many hydrogens do I have on the left? 4. Oxygen atoms on the left?
2.
Oxygen atoms on the right? 2. See how that multiplies all the way through? Make sense? Okay. I changed the coefficient, so what should I do? I should go right back and check the whole process again. Okay, and in checking the whole process, it's going to total out and everything should be good. Okay. Variety of ways we can test you on this. One is just having you provide the equation. The problem with providing that equation is how many of you don't have to answer, didn't need to specify all the work that I just went through and did. Okay. There's probably a couple people that don't need to do that work. Okay. I get it. That's why I tend to not ask this kind of question in a show your work. If I'm going to ask about balancing, it would be in a multiple choice where you have to deal with it there. Does that make sense? So sometimes people can pull off inspection. When it comes to show your work questions, I try to establish questions that are not possible via inspection. Okay? It's not always true, but that's what I aim for. So how could it get asked in multiple choice? What's the coefficient in front of water? 2. What's the coefficient in front of oxygen gas? What's the sum of the coefficients from the balanced equation? 5. Okay? That 5, 1 becomes tricky because we do have to remember there is a 1 technically in front of the oxygen. Make sense? Okay. So lots of different ways that can get tackled and asked. Which then sets us up with this next question. This next question gets really nasty and trips a lot of people up because it reads right off the bat, for every 1.00 mole, what the hell's a mole?
A measurement.
Okay. At this point, all you need to know is it's a measurement. Okay? That's all we care about. You don't need to know anything else beyond that. So if you take this question to a tutor, they'll be like, oh, well, a mole is blah, 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 and start defining things. Irrelevant. You don't care. Okay? Which is a really dangerous statement for a chemist to say about moles. Maybe I'm not a very good chemist. Okay? I think mole day is stupid. I shouldn't quote that. Okay? Do you know the beauty of a mole? We'll talk about it in the next unit. The one beauty of understanding and defining what a mole is that you never have to do it again. That's it. That's the one beauty. Everything else, all the numbers and stuff that you end up calculating with it, ultimately, you never have to stress about what a mole is ever again. It's neat. Okay, we invented something so that we could forget about it. Okay, so how do we use it? Well, let's start processing this out. Let's take this text and turn it into some useful information. For every 1 mole of oxygen consumed, so that says for every 1.00 moles of oxygen, note we have a number, we have a measurement, that says measurement, and we have a substance. That should look really familiar, right? What should that look like? The information that was provided to you in the background information for our very first lab for Chem 130. Huh. It's almost like it's directly relevant. Yeah, it is. Okay, so 1 mole of oxygen gas, I'm specifying all that information. Okay, for every 1 mole that is consumed, 2 moles of water are produced. What I actually just wrote out in the English language was an equality. Whoops. Helps if you use the right numbers and the right sig figs. One mole of oxygen is 2 moles of water. Where did that come from? That's a harder question, for the record. Little outside the scope of this particular unit. What's the coefficient in front of water in our balanced chemical equation? What's the coefficient in front of oxygen? 1. Where did this conversion come from? It came from the balanced chemical reaction, or the balanced chemical equation. We're using that information. Okay? So we've got that statement. It then said if 9 grams of oxygen, okay, so I have 9.00 grams of oxygen, okay, and then it's got this weird parenthetical. I've got 32.0 grams of oxygen equals 1.00 moles of oxygen, okay, are consumed. Then how many grams of water are produced? So we've got more information coming out of this. Okay. As someone carefully reading the question, that says how many grams of water, so what am I being asked to do? I want to know the grams of water. That's what I'm being asked to solve for, the grams of water. Right, how many grams of water are produced? And then they drop down yet another obnoxious equation, out of colors. Let's go to purple. 18.0 grams H2O equals 1.00 moles of H2O. And you know what the average student does right now? Hyperventilates and panics and says, I was never taught this. Okay. At this point, you sort of have a fair argument, okay? Because we haven't talked about conversions yet. But starting next week, we talk about conversions. Okay, so let's walk through what we talk about with conversions. Step 1, let's take all of that English text and turn it into mathematical expressions. So we've done that. Okay. Step to really harp on what you're trying to get to. I want grams of water. Okay? And I have to run some kind of conversion, some kind of calculation process. And if I'm going to run a calculation process, that probably means I'm going to need an equal sign. Okay? And that equal sign should give me the answer I want, grams of water. Okay? So if I'm, oh, that didn't work. Let's try that again. I don't have that much space. I needed that space. That works. I want to know that question mark. Okay? Which means what I now need to do is take all of this information I've been given and structure it so that the units cancel out and I end up with grams of water. That's what I want. Okay? So where should I start? And this is a nasty question when it comes with conversions, because where can you start? Anywhere. Right? Anywhere you want. You can pick any of those conversions and enter them into this calculation. The problem becomes, how do you know where to place those individual conversions? Should you place them in the numerator or should you place them in the denominator? Okay? So what I would argue we should shift to is away from this formulaic system. Multiply by grams by molar mass, divide by this and that, and stop that and just track the units. What do I want for an answer? Grams of H2O. Let's look at the very first conversion. It says moles of oxygen. Is that what I wanted? No. It says moles of H2O. Is that what I wanted? No. It's the substance, but not the measurement. Okay? How about the next one? It says grams of O2. Is that what I want? No. How about the next one? Grams of O2, moles of O2. No. How about the last one? Ooh. That last one does bring in the units of grams of H2O. Okay? So now let's push on what that equality means to us. That equality means a couple different things. I can make that equal 1. How do I make it equal 1? Put it over itself. So I could divide both sides of this equation by 1 mole of H2O. What is this now in the parentheses? You know better than a fraction. That's 1. Okay? And anything multiplied by 1 is 1, which means I can put this 1 wherever the hell I want, and it does nothing to the overall meaning. Cool. Okay? Do I want to use this 1? Well, this 1 isn't particularly useful, but I know this 1 equals this. Right? I also know, by dividing the other way, that I could get 1 mole of H2O over 18.0 grams of H2O. What does that equal? One. Okay? So the question becomes, which one do I want to use? What do I want? I want grams of H2O. Located where? In the numerator. Does this blue one give me grams of H2O in the numerator? Is that going to be a useful one? No, that's pretty useless, so let's get rid of it. Does this one give me grams of H2O in the numerator? It does. Because it does, what I can now go through and do is include it. I want grams of H2O in the numerator, but where is it coming from? It's tied to moles of H2O. What number should go where? Should I place the 18 on top or on bottom? Okay. Definitely a jerk question. I got a lot of people telling me on top. Here's the jerk answer. No. Does not belong on top. Where does it belong? In the numerator. No, it does not belong in the numerator. Well, it doesn't belong on top. Where else does it belong? On the bottom. Also wrong. There's only 2 spaces, Mike. That's BS. You can't do that. Yes, I can do that. Because it doesn't belong on the top or the bottom. It belongs with the correct unit. That 18 goes with grams of water. So when the unit changes locations, guess what happens? The number changes locations. If you start saying the number goes on top or on bottom, when you go through to solve, guess what you're going to do? Start putting the number on top or on bottom, not tied to the proper unit. The number's associated with the unit. Keep it with the unit. What number goes with moles of H2O? 1. And if we want to be real fancy, 1.00 moles. Cool. So we just manipulated all of that. We got a whole bunch of information, and we don't have our answer yet, right? How do we know we don't have our answer? The unit that I wanted was grams of H2O. What unit do I have? Grams of H2O and moles of H2O. I don't want moles of H2O. So what needs to happen to the moles of H2O? It must cancel out, which means I have to do another calculation. In that other calculation, what do I know needs to be present? Moles of H2O. I know I need moles of H2O. Why? I need it to cancel out. So not only do I know I need moles of H2O, I know where to place it. Where should I place it? Cool. Do I know anything about my moles of H2O? Okay. So one option is looking at the top. We're not going to look at the top. We go, oh, 18 grams of water is equal to 1 mole of H2O. That is moles of H2O. That's perfectly valid. You could go through and do that. If we plugged in that system, what did we just do? Okay, so what we're saying is we know grams of H2O, and we know all this. Right? That's perfectly valid. I'm allowed to do that. Do I want to do that? Why not? Moles of water cancel. Great, I didn't want the moles of water. And grams of water cancel, which means I'm right back to square one. That doesn't get me closer to grams of water. So, not a good conversion to use. I know I need moles of water, so I go back through my equations. Where do I have moles of water? Orange is in it, blue is in it. Top one, which is a mixed color, I apologize. Okay, we'll call it red, does have moles of water. Is it just moles of water? No, it's moles of water related to moles of oxygen. If I've got moles of water in the numerator, what's going to have to show up in the denominator? The moles of oxygen must show up. This says 2 moles of water. Where does the 2 go? It goes with the moles of water. Not on top, not on bottom, with the moles of water. Focus on tracking that unit. What goes with the moles of oxygen? 1.00. What happens? Moles of water cancel. Good. I didn't want moles of water. Do I have my answer? No. What's wrong? I also don't want moles of oxygen. So what does that mean I need to do? I need to cancel it. And to cancel it out, what do I know needs to happen? Moles of oxygen must appear on top so that those units can now cancel. Do I know my moles of oxygen? Where does it just say moles of oxygen? Okay, orange or yellow, however you want to call it. Does that just say moles of oxygen? No, so I would argue we don't know the moles of oxygen. We know the moles of oxygen related to the grams of oxygen. So moles of oxygen is fine in the numerator. What do I need to drop into the denominator? What numbers do I need to bring in? 1.00 with my moles of oxygen and my 32.0 with my grams of oxygen. I'm associating the numbers with the units directly from my expressions. Now what? Am I done? No. Moles of oxygen cancels. Great. I didn't want that. But do I have my final answer? No. I have grams of oxygen. Do I want grams of oxygen? Nope. So what has to happen? That unit must cancel. So now I go back. Do I have the grams of oxygen? Yeah, I'm actually explicitly given 9.0 grams of oxygen. What's in the denominator? Okay. There's a couple answers that usually get floated. 0 becomes an interesting one. What's 9 divided by 0?
60.
Or infinite. You get weird calculations with that. Enter it in your calculator. It usually breaks it. Okay? So dividing by 0 is problematic. Okay? That's also going to change the value of the 9. We were told it was 9, not 9 divided by 0. So what do I put in the denominator so that my 9 does not change? 1. What unit goes in the denominator? No unit. Because if I put any unit in there, it's not 9 grams of oxygen. It's 9 grams of oxygen related to something else. Do I now have my answer? I would argue yes. Okay? But yeah, now all you do is multiply everything out. This is a conversion process. Everything in the numerator, personally for me, I would break it into two kind of calculations. I do everything in the numerator and multiply it out. Oh, I would love to say I could do that math in my head. I can't. I can do 9 times 2 is 18. Times another 18. My dad's probably pissed at me that I can't do that one, but I can't do that one. Okay, and then I would also go through everything in the denominator and multiply it out. 1 times 32 is 32 times 1 is 32. Now I'd enter it into my calculator and get an answer. A couple people have calculators. What number does it spit out? $10.125. It didn't spit out any units? No, because calculators don't spit out units. That's why you did the unit process, so that you know what unit it gets tied to it. What unit is tied to it? Grams of H2O. Right? So cool. Now we set it up. Do you know what a mole was? Nope. Did you need to? Nope. You just needed a process to follow to do conversions. That's it. Right? And I can probably guarantee you that the process you've used to do conversions in the past was memorize that this conversion exists, and you either multiply or divide. If I ask you to show the work to convert from 36 feet, inches, let's do inches. I can do inches better. 36 inches into feet, you're like, oh, I just divide by 12. No, you don't. You divide by 12 inches and you multiply by 1 foot so that your units convert across also. Okay? You've been triggered and trained to think solely about the numerics of your calculation. The numerics only hold so much value, and that value is instantly lost if you don't understand what the number is tied to. And I can almost guarantee you that you will never figure out what a mole is. Why? Because it's a stupidly large number that the human brain can't comprehend. That's why we created a mole. Okay? That's why it exists. Kind of, sort of? Does that make you feel better or worse?
Probably worse.
Probably worse, yeah. Okay? Why?
I don't know. I guess, like, looking at the question itself, like, it seems like almost like a simple word problem, like 9 grams of oxygen. How many grams of water? There's 18 grams of water in one. Like, I don't know. It seems like it'd be a little bit more straightforward than that. And I'm sure I'll be able to work it out.
And that becomes the misleading part. So you go, well, why do we have to do all of those calculations? Okay. Any way you structure this, anyone you talk to is going to run these exact calculations. Every single person. The question's going to become, how did they do those calculations? And in most scenarios, they ran those calculations because they knew that was the answer to run those calculations. That's not useful. That's called, effectively, cheating. Okay? And because it's really hard to cheat on an exam, that's not helpful for you to process. You need a process that allows you to convert these individual units all the way through, step by step by step. Okay? Insult to injury, multiplication is communicative, which means I can run those calculations in any order I want. Which means depending on who solves this question, when you look at the order that they run the calculations, it could be different. That doesn't mean they're doing it wrong. That means they saw a different path through the forest. Okay? The questions that were asked as we solve this become the critical ones. Okay? How many people wrote down why I did moles of water over moles of oxygen? How many people even wrote down the question that I asked that got us to that conversion factor? I would bet what you wrote down is what's written up here. Does that explain the process by which you got there? No. So when you go back to now do your homework, you're going to be like, well, I don't know how to solve it. How did they get the order of these things? Yeah, because you didn't take notes on the process. You took notes on the answer. And if you're like, well, the answer makes sense. That's why it's called an answer. Stop looking at the answer. Look at the process. And that's very hard to do. Kind of, sort of? Questions about it? It was conveniently recorded, so you could go back through and be like, what was that process? What were those questions that were asked as we navigated each stage?
Is that the right way of saying it?
Okay. Is this the correct answer? Of course, no, it's not the correct answer because we've run a calculation, and when we run calculations, what do we also have to trigger and follow those with? Significant figures. Okay? So we could go back and look at all of our numbers that were given to us and see how many significant figures were used. We didn't do any addition subtraction, so we don't have to worry about those rules. All we have to worry about are the rules of multiplication division. And we go through and look at all of our numbers. How many sig figs were we given? 3, which means our answer is 10.1, and I dropped the 2.5. Okay? Did this question ask about sig figs? That's a harder question. Okay? How we're looking at it right now, the sig figs are implied. That's part. Every calculation you run, you have to pay attention to sig figs. Okay? Is there another tool you could use to figure it out? Yeah, there is another tool. It's called test-taking strategies. Let's take a look at what our answer choices were. If this was raw multiple choice, or not multiple choice, show your work, it's implied you got to know it. Can I erase? Did this question ask about sig figs? Look at those answer choices. Only one of them is 10. This question isn't asking about sig figs. The multiple choice tell you right away what your answer is. You run the calculation, whichever answer comes out close is fine. And you're now done. Now sig figs is implicit behind it, not explicit. Make sense? And then the next thing to make you feel worse, I apologize, that's all I do ever apparently, is make people feel worse. Look at all those other answer choices. Okay, what's fun about those answer choices? We did 9 times 2 times 18 divided by 32. So there's a couple different calculations you ran in there. What if you did 9 times 18 divided by 32 times 2? That's an answer choice. What if you did 2 times 18 divided by 9 times 32? Answer choice. All the possible permutations of how you could jam those numbers together, not all of them, but most of them, are answer choices. Which means when you go through and run a calculation, just because you see the answer does not mean you are correct. You need to know what your process is and the work to get you there. Does that make sense? Hooray! Can we do something easier? Did we flog that one enough? We good? Okay. And if you're stressing about conversions right now, hold your breath, stress about it next week. Don't hold your breath till next week. Wait. Worry about all the balancing and chemical formula stuff. Worry about conversions next week when we actually start looking at those processes and start working with simpler conversion units. Okay? Should we do the last final nail in the coffin on this question? Okay, let's just clear it all away. This question is going to potentially show up again, but it's going to change. Now you're looking at the third unit. What changed? 9 grams of oxygen are consumed in the reaction with hydrogen gas to produce water. Then how many grams of water are produced? What changes now about the question? What's that? Nothing is given. All of those conversions that we wrote out that were given in the question are now things you have to know where to find. Yay! Welcome to chemistry. Guess where a lot of those things are found? Periodic table. You just need a little bit of context to know where that information is so that you can pull it off the periodic table. Okay? Next question. If you get dizzy looking, don't look. Sure. Is that kind of small? Sure, kind of small. Let's see if I can make it bigger. I'm not sure I can. Ooh, maybe I can. Nope, I can't. That's as big as it gets. That's kind of a lie. I'll rewrite it so that it's bigger. Okay, as far as that rewriting, I will rewrite it so you can see it a little bit bigger, but what I'm going to ask you to do is start this process of dealing with the balancing. So, while I'm rewriting it, if you can see it, you can already start that process. So start trying to figure out how to balance this structure or this equation. If we look at the process that I've gone through and started, we looked at gold, okay, or AU, however you want to look at it. Okay, we had 1 to begin with on the left-hand side, and we had 2 on the right-hand side, because that 2 applies to what's in front of it, yeah? Okay, sorry. So to ensure it's balanced, I would need a 2 over here to ensure my coefficient comes out. Okay? That, in and of itself, is the approach. So now what's the next step? I find the next thing I want to go through and balance, and I look at that. And then I find the next thing I want to balance, and then I look at that. What I frequently see students doing, we'll backtrack it. I need to remember to use a better eraser there, is going through and doing something along these lines. Well, I've got 1 gold, 2 gold, I've got nitrogen, I have 3 over here, I have 1 over here, I have oxygen, oh God, 9 and 4, 13? It's 13. 3 and 4 gets me 12, plus another 3 gets me 15. I got my potassium, I've got 2 over here, I got 1 over here, chromium 1 and 3. I already did the oxygen, so we're good on that. Okay? And then people double back and say, well, how many golds? Well, those didn't balance, so I'm going to adjust this. Hold the way the hell up. Okay? As soon as I change that 2 on that gold, what does that do to my nitrogen? It changes it. What does it do to the oxygen? It changes it. You went through and counted the number of nitrogens and oxygens prematurely, which means you're going to duplicate your work. That's why I don't show it that way. But that's why when you look at the final answer of the work, it sure looks like that's what I've done. This is why you have to watch and pay attention to the process as we navigate, not the final answer. Does that kind of make sense? Okay. Next thing I want to throw out there to make sure you're aware of. Okay? You already heard me stumble over the oxygens, and I probably actually butchered it. Hopefully I didn't. Okay? There's a whole crap ton of oxygens. As soon as we start changing coefficients, the count of oxygens is going to go through the flipping roof. Okay? And if we push back on it even harder, look at where oxygen shows up in the equation. Everywhere. Oxygen's going to be really, really hard to balance. Okay? So if you're going to structure your balancing going based off of atoms, oxygen should not be early in your list. It needs to be at the bottom of your list. Okay? And what we're hoping is that when we balance everything else and we get to the oxygen, it already balances and you don't have to worry about it. But even then, it requires you do math. Okay? Here I'm at 13 and 15, and I didn't do any multipliers yet with any of the coefficients, which means those numbers are going to change a lot. Okay? When we get into conversions and dealing, we actually already talked about it a little bit with our powers of 10. Okay? We do powers of 10, we do milli, centi, and all of those things. Why? Because we suck at counting. Okay? And arguably, humans are really only good at counting up to one particular number. And even that's pretty freaking questionable. What's that number? 10. Because you have 10 flippin' fingers. That's it. If you got a number higher than 10, you're going to screw it up. Sorry. Right? So we want a system that allows us to not have to count that high. That's why we invented prefixes for our individual units. So I don't have to be counting billions of millimeters to measure the length of a desk. Right? Because that would be obnoxious. Make sense? Okay. So how can we fix this? The fix, number one, is we go all the way back to the beginning, we're looking at gold. Okay, gold was straightforward right out of the gate, so we can use that one. Again, we've got the 2 floating off the screen up there, but it is there. Okay, we could show our work here. Now, what's the next thing I want to balance? You can absolutely go atom by atom. It is perfectly fair. You are allowed to do that. Okay? Again, atom by atom could mean lots of math. Instead of looking at nitrogen, where is nitrogen connected? To 3 oxygens on the reactant side. What is it connected to on the product side? Did it change? No. So instead of balancing nitrogen, I can balance NO3. NO3, also known as nitrate, sort of, NO3 in and of itself is not nitrate. How do we make it nitrate? It's a -1. How do we know it's a -1? That would be dealing with the charges. There's probably questions about that. We'll double back to dealing with charges a little bit later. Okay? But for the sake of balancing, all we really care about is the number of the elements, so we're looking at NO3. How many NO3s do I have on the left? Okay? So the left would be over here. There's my NO3. And what I'm hearing people tell me is 3. There are 3 NO3s. Some people want to dispute that. That's good, and maybe you're disputing it because you've written it down on your page as opposed to looking at the screen. Because if we look at the screen, we might be missing that there's a 2 in front. That 2 applies to everything afterwards up to a mathematical operator. There's my mathematical operator, which means I have 2 golds and I have 2 times whatever's set in that parentheses. Which means how many nitrates do I have? I have 6. How many nitrates do I have on the product side? Or the right-hand side? 1. Is that balanced? No, I don't want to count anything else. I just want to deal with nitrate. To make that balanced, what do I need to do? Put a what in front? A 6 in front. That 6 will now apply to everything afterwards, the potassium and the nitrate. So far, so good? Hank, was that a question? Just checking. Now I'll move to the next thing on my list. What's the next thing? Potassium. How many potassiums do I have on the left? 2. How many potassiums do I have on the right?
6.
I have 6. Because I've put that coefficient in there, I've already counted, and I know that that's now 6. Right? If I'd counted the potassiums first, I would have had a number 1 there, and I could have gotten confused because it's not a 1, it's a 6, because I changed the coefficient. Does that make sense? Is my potassium balanced? What do I need to do? I put a 3 in front of the 1 on the left. That makes it 6. Why does it not make it 3? It's 3 times 2. There's 2 potassiums in every one of those units. So what this says is I have K2, whoops, let's write it out slightly differently. KCrOOOO, right? But I have 3 of these. How many potassiums are there? 6. And if you're like, I don't want to have to write that work out, are you balancing correctly? If your answer is yes, then don't write it out. If your answer is no, you're not balancing properly, then you should be writing out every single chemical formula so that you can see every single atom so that you can start totaling those things appropriately. Is that painful? Yeah, learning is painful. That will help you ensure that you can figure it out and you can start to simplify your process. Make sense? So our potassium is now balanced. What's next? I could look at my CrO4. How many CrO4s? Which is kind of painful to go through and say. I have 3 on the left and I have 3 on the right. I changed coefficients, which means what should I do? I should double back, go all the way back up to the gold, and check gold. Okay? In my check of gold, how many on the left?
2.
On the right. How many nitrates on the left? 6. Okay, remember there's the 3 subscript and the 2. On the right.
6.
Potassium's on the left.
3.
6 because of the subscript next to the potassium saying I have 2 potassiums, and now I have 3 of those 2 potassiums, which gets me 6. On the right, chromates, 3 and 3. I didn't change any of the coefficients, which means it's balanced. Eden, better or worse? That's absolutely fine. You have to follow a very methodical process for looking at each of those elements and counting those numbers out. Okay? And again, if you're struggling with this kind of balancing system, what I would recommend, okay, it's going to take up a massive amount of space here, but I'm going to try and pull it off, is that you go through for each of these units. This is AUNO3, so it's AUNO1, there's 3, but I have 3 of those. That very first formula means that. What's the next one? That next formula means that. Oh my God. 1, 2, 3, 4. 1, 2, 3, 4. The next one. With it written in this format, it should make it easier to go through and count how much do you see of each of those individual pieces. How many golds on the left? There's only one atom versus 2, which means I need a 2 in front of this. Okay? And it builds out the exact same process. Writing it out this way, you might be able to balance the oxygens easier because you can now count them all out. Okay? I would hope that you only have to do this process a couple times before you get used to knowing what those formulas mean so that you can then shortcut that process. But if you are struggling with the balancing, you need to do what I've written on the bottom. As painful as that is, you need to prove yourself all of those individual pieces. You had a question?
Would you accept both, like if you did all of the atoms by themselves balanced?
So balancing, again, this pushes kind of those gray area spaces. Could you do a balancing question by inspection? Yeah, which means there's no work. Okay, so when we're talking about balancing questions almost universally are found in the multiple choice. Okay, which means your work is not graded. Do whatever work you want. Okay, when it comes to paper homework, as long as you're showing work, I don't care. Okay? So if you want to balance it out by atoms, absolutely. My only caveat is you're making life harder than it needs to be. It's already hard enough. Okay? But if that's how you get it consistently right, do it. Make sense? Should we do another one?
Yes.
Okay. Just looking at them, I think I somewhat, like, as I scanned through, I was like, that one looks really, really hard. And of course, that was the one I picked. So let's shift. Next one down's a little bit better. Do you want time to work on it on your own or go through it? Just go through it. It's again kind of small, so aluminum. Whoops. Where do we start? Oh, yeah, I put the parentheses, but I didn't drop the number in. That's the 2? Yep. I would love to say I did that intentionally. Okay, where do we start? Aluminum. How many aluminums on the left? 1. How many aluminums on the right? 1. What's next? How good are we at our nomenclature there? CD, also known as cadmium. How many cadmiums on the left? 1. Cadmiums on the right? 1. Okay, so it's balanced. So now we move to? Oh, you take all the fun out of asking what it is. C2H3O2 is also known as acetate ion. That is one that you are required to know. How many acetates are on the left? 2. We're looking at the parentheses. That 2 is our multiplier inside it. How many acetates on the right? 3. So it doesn't balance. We're going to need to go through and change this. How do we change it?
Add a 2 for the cadmium.
We're not balancing cadmium. We're not balancing cadmium. We're balancing acetate. So all I care about is the acetate. Technically, what we're going to do is the exact same thing we did every other time. Okay, when we had gold, we had 1 and 2. We made the 1 into a 2. Why? What's the lowest common multiple between 1 and 2? 2, right? So how do I make the 1 into a 2? I multiply it by 2. What's the lowest common multiple between 2 and 3? 6. So what do I need that 2 to become? A 6. How does it become a 6? I multiplied by 3, which means what goes in front of the cadmium? A 3. How do I make the 3 into a 6? I multiply it by 2, which means what goes in front of the aluminum? A 2. Okay? We've now balanced everything. Are we done? No, why not? We changed our coefficients, which could change some of our earlier balancing, which means we go back and we check. How many aluminums on the left? 1. Aluminums on the right? 2. What's the lowest common multiple between 1 and 2? 2. I need a 2 in front of the aluminum. Okay. Check the cadmium. How many cadmiums on the left? 3. How many cadmiums on the right? 1. Doesn't balance. What's the lowest common multiple between 3 and 1? 3. So I change the coefficient in front of the cadmium to 3. I check the acetates. How many acetates on the left? 6. Acetates on the right. And 6. Is it balanced now? Hooray! And we now have a proper equation that has everything balanced out. Kinda, sorta? We feel a little better? The process of balancing just takes a little bit of practice of going through and being very methodical behind it. Okay? This process, I would argue, is the same as the process for nomenclature with dealing with balancing out charges. It's the same general process that moves through, which is why when we do nomenclature, I push dealing with formulas and balancing out charges, because I want you to used to that balancing process. When you move to the lectures at the end of this week for oxidation, you do the exact same thing. So if you're used to that process, it should get easier as you navigate, and what you're starting to work on is now not running calculations, but what is the meaning behind what you're working on. Okay? With that said, we are done.